In this lecture, we discuss about the different applications of eigenvalues and eigenvectors. Eigenvalues and eigenvectors have broad applications across various fields, playing a critical role in solving complex problems and analyzing systems behavior. Understanding these concepts provides valuable insights and tools for engineers, scientists, and researchers. So let us take one by one application. What are the applications in mechanical engineering? So first application is in vibration analysis, determining natural frequencies and mode shapes of mechanical systems. Stability of structures, analyzing the stability of structures under different load conditions. Model analysis, studying the dynamic behavior of structures. So these are some applications in mechanical engineering of eigenvalues and eigenvectors. The second field is electrical engineering. What is the applications of eigenvalues and eigenvectors in electrical engineering? The first application is in circuit analysis, analyzing the behavior of electrical circuits, including RL circuit also. The another applications of eigenvalue, eigenvector in electrical engineering is the control systems, designing and analyzing a stable control system. Then the third application is in power systems, studying stability and dynamics of power grids. Now let us take what are the applications in computer science. The first application is Google's page rank algorithm, ranking web pages based on link structure. Facial recognition, using eigenfaces for recognizing faces. Data compression, principal component analysis for reducing dimensionality of data sets. Machine learning, feature extraction and dimensionally reduction techniques. So these are some applications of eigenvalues and eigenvectors in computer science. Next one is the physics. In physics, eigenvalues and eigenvectors are used in quantum mechanics for solving the Schrodinger equation to find energy levels and quantum states. And the second, molecular vibrations, analyzing vibrational modes of molecules. Solid state physics, studying the electronic properties of materials. So these are some applications of eigenvalues and eigenvectors in physics. In economics, Markov chains are used to modeling economic systems and studying state transitions. Then portfolio optimization, analyzing covariance matrices to optimize investment portfolios. And ecometric models, stability and dynamics of ecometric models. So these are some applications of eigenvalues and eigenvectors in economics. Environmental science, population dynamics is used to modeling growth and interaction in ecosystems. Climate modeling, which analyzing stability and long-term behavior of climate models. And pollution spread, studying diffusion processes and con contaminant transport. So these are some applications of eigenvalues and eigenvectors in environmental science. What are the applications of eigenvalues and eigenvectors in finance? The first application is in the risk management, analyzing covariance matrices for portfolio risk assessment. The next is the interest rate models, studying the dynamics of interest rates using eigenvalues. and then credit scoring, utilizing eigenvectors in credit risk models. And then what are the next application? Is it in structural engineering, model analysis of building, studying the response of buildings to seismic, seismic activity, bridge dynamics, which analyzing the vibrational behavior of bridges, finite element analysis, eigenvalues and eigenvectors in solving finite element equations. Now, its next use is in the robotics, kinematics and dynamics, analyzing robot motion and stability, in control algorithm, designing stable control algorithm for robotic systems, and path planning using eigenvalues in optimizing robot paths. So these are the some applications in robotics. The next is the signal processing or electronics engineering. The first application is in the Fourier transform, eigenvalues in frequency domain analysis, image processing using eigenvalues for image compression and feature extraction, and filter design, designing stable filters using eigenvalues analysis. The last applications is in chemistry. The first thing is the molecular orbitals, analyzing the electronic structure of molecules using the eigenvalues and eigenvectors. Then reaction dynamics, which is useful in studying the kinetics of chemical reactions. And spectroscopy is used in this spectroscopy's eigenvalues in interpreting spectroscopic data. These are some applications of eigenvalues and eigenvectors. Thank you.